All right, so we are comparing and ordering real numbers, part 2. We are looking at some properties of numbers today. We're going to have some vocab for you. Let's start with simplifying. What happens if you have a negative times a negative? Katso? Yeah, it becomes a positive. So in that first example there, you have a negative times a negative, which creates a positive 7.2. Okay, and number 2, you have 1 minus a negative 3. So a minus also becomes a, Sierra? Perfect. So the minus a minus becomes positives. So that's really the same as 1 plus 3, which is if I add 2 negative numbers together, then my number becomes more negative, right? Becomes a bigger negative. So negative 9 and negative 4.5 becomes negative what? Negative 9 and negative 4.5 will become what? Yes. Okay, number 4. You have negative 3.4 times negative 2. So a negative times a negative becomes a perfect. And 3.4 times 2? Perfect. A negative divided by a positive is a, Sierra? No. The 5 is good. Exactly. You need a negative in there because the 15 is negative, but the 3 is positive. So my answer stays negative. All right. This is a little bit tricky. We can take this negative and bring it up top. So 2 fractions or any fraction, you can move your negative around. So that's the same as negative 2 plus negative 3/5. Do these fractions have like bases? Do they have a common denominator? Yeah. So if 2 fractions have a common denominator, we group the numerators. So it's really like negative 2 plus negative 3 all over 5. What's negative 2 and negative 3 give us? What you got, Sierra? Damn, that's the second time you did that. Yep. So you get negative 5 on top and a positive 5 on bottom. Don't lose your negative though. I heard the 1. It'd be negative 1. Unless you said negative 1 and my ears are just failing me. Thank you. Okay. All right, that leads us into some new vocab today. So we're going to talk about the real number system. And we classify numbers in many ways. One of the ways we classify them is by labeling them. So when you were little kids, probably parents taught you how to count. The natural numbers are the counting numbers. So when you were like 2, 3 years old, they would try to get you to count from 1 to 10 correctly. So you'd be like 1, 2, 3. We call those the natural numbers because they're the numbers you learn first. They're the counting numbers. They're the ones you can do on your hands. So the natural numbers are the numbers you learn. And then when you got to like kindergarten, your kindergarten teacher taught you how to count to 20. Then she taught you how to count to 50 and 100. Those were still the natural numbers. The only difference from the natural numbers to the whole numbers is the special number 0. 0 is the whole number added to the natural numbers. It's the only one. It's the only different number. Then you got older and you learned about negatives. Right? So the negative whole numbers, meaning there's still we don't know about fractions yet, are the integers. So the integers are the natural numbers and all of their opposites plus still 0. I filled in some of it for you. Make sure you're getting the rest. Then you got really good at math, aka now. And we talk about the rationals and the irrationals. The rationals and the irrationals are all the mathematical numbers you despise. That's our fractions. It's what we talked about yesterday with terminating and repeating decimals. So yesterday when we turned fractions to decimals, when we made them a decimal, we described them as terminating or repeating. The irrational numbers are those numbers that don't have a nice repeating decimal, and they cannot be a fraction. Irrational numbers cannot be a fraction. Do not ever tell me a fraction is irrational. Fractions are very rational. We use the symbol Q to describe a rational number because Q stands for quotient, and quotient means division. And guess what, guys? Fractions are really just division. We'll blame all those old men mathematicians for all these crazy words.
All the time. Write the answer. Write it sometimes in form C up to square root 11. Sometimes you can write the answer like that. Sometimes you write a decimal and you fill in 2 decimal places, 1 maybe 3, depending on what you're asking for.
Okay, so I know you guys are copying that down. I'll give you a few minutes. Make sure you fill in all of the spaces on your table. Okay? Is everybody good for copying? Can I switch slides? Was he? We'll turn to the next page and we're going to fill in the boxes above it. The slides go. I just never filled out my slides. So stay on this page. We're going to do the top one. Let me just print these for you. Circles, yours are squares. They still work the same. Mine are circles, yours are squares. But basically, we want to start with looking at two things. The real number system is divided into two parts. Maybe not as equally as mine is divided, but it is divided into irrationals and rationals. A number can never be both. A number can never be both. So you got the irrational numbers over here. That's your pi. That's your number that has no nice pretty decimal. It just goes on and has no pattern. It cannot be turned to a fraction. Those are the irrationals. They're the messy numbers. The rationals are the pretty numbers. That's my fractions, my repeating decimals. They're the ones we like to be friends with. So that's the rationals. Then the rationals get even smaller. So you could have a number that's an integer. If a number is an integer, it is also rational. Does that make sense? If a number is an integer, it is also rational. So like -3. Can't I technically write -3 as a fraction? How could I write -3 as a fraction? Put it over, not 0, 1. So -3 could be considered irrational if you wrote it over 1, but it's still an integer. So then you have your whole numbers, which are 0, plus all the natural numbers, which is your 1, 100, 1,000,000, 1,000, etc. So again, the integers are the negative naturals. The whole numbers are all the natural numbers and 0, etc. So we can categorize numbers into one of those or many of those. Ooh, I left my answers on here. Okay, so now let's talk about describing them. The square root of 4 can be simplified to what? The square root of 4 can be simplified to 2. The square root of 4 can be simplified to 2. So what we want to do is simplify before we describe. So negative square root of 4 becomes negative 2. And it says, to which sets of numbers does this belong? Well, for now, every number we talk about belongs to the real numbers. So get yourself a free point and put down real. Is this number pretty or messy? Good? It's pretty, right? So it's not irrational. So therefore it is rational. And it's negative with no fractions or decimals, which makes it an perfect. Makes it an integer. Very good. Okay, point 2, repeating. What category do repeating decimals fall into? Where does a repeating decimal go? Abby? The rational. Very good. And remember, everything is real. Everything is real. Okay, the square root of 8. Somebody on their calculator type in the square root of 8. Pretty or messy? Sierra? Messy. So a messy number is what? Yes. So you get a real, irrational, zero. So what is 0? Is it real? Can I make 0? Go ahead, Zoe. What do you think? It's rational. Is it anything else? Does 0 go on the number line? Yeah, so that makes it an integer. So the integers are like your number line numbers. And, go ahead. Yeah. So 0 gets a lot of descriptions. It's a real, rational, integer whole. Remember I told you we kind of flowed down on the chart. So if 0 is a whole number, it's everything above the word whole numbers. Okay, 4/5. 4/5. What is 4/5? What do we call that type of number? It is a what? It is rational. And then pi. I could go for some pi right now. What do we know about the pi? Yes. Yeah, because does pi have an ending? Does anybody know what the value of pi is? You guys both raised your hands so confidently. What do you think, Logan?
3.144, etc.
Yes, exactly. I love the etc. because there is a computer's what? You know even more of them? You know 100 digits of pi? Wow. I don't know 100 digits of pi. Me too. All right, guys. So, which even at that, the pi symbol in our calculator is limited. It doesn't actually have the value of pi to it. So, what I want you to do now, do you see how I have colors up in the problems? Those colors match their dots on the number line. Can you also draw your graph points on the number line and match them? So like number 1 is -2. So I'm going to write a number 1 with my yellow dot. 0 is problem 4. Or at least like draw an arrow so you know which one is which. I used the colors to help me indicate. Okay. And then we already kind of talked about this yesterday. We hinted at what was the opposite or additive inverse of any number A. So what's the opposite of A? Ed Logan? Perfect. What? Do you not have these on your notes? We'll skip it. Maybe I put them on tomorrow's. I mean on next week's. But you have stuff at the bottom, don't you? Just comparing. All right, let's do the bottom of that. So a big part is to graph numbers and to order them from least to greatest. So the easiest way to graph a number is to turn it into a decimal. So that's what a large part of yesterday's lesson was, turning values into a decimal. So let's